Hello and thanks for watching the next in our series of videos on GCSE Maths Algebra, and this time we're going to be covering solving linear equations, and we're going to do examples which range from doing more simple ones up to more complicated ones. So the first question that we're going to look at is one where we've got x plus 5 equals 8, and what we've got to try and do is work out the value of x. So we use this method where we try and get x on its own on the left hand side of the equation. So by the left hand side I mean we've got two sides to this equation. We've got the left hand side of the equals and we've got the right hand side of the equals, and we're getting the x eventually. We're hoping to get the x on its own equal to something. And what we can do is we can try and get rid of things on the left hand side that we don't want. So for example, we don't want this plus 5, so we can do the opposite to that, and we can take away 5, but the trick is we have to do it from both sides, so we take away 5 there as well. So if we do that, on the left hand side we're left with just the x, because a plus 5 and a minus 5 cancel each other out, and on the right hand side we're left with 8 minus 5 is 3, and that's it, we've done it. And just to talk about the reason why we do the same thing to both sides is because what we're doing is we're balancing the equation. And what that means is we can almost imagine that the equation is a bit like a seesaw. And so on one side of the equation we've got x plus 5, and on the other side we've got 8. And that's like saying it's equal to each other. And so if we do something to one side of the equation, we have to do the same to the other side. So the point is we always do the same thing to both sides. And the reason we do that is because we want to keep the seesaw balanced. So if I take away 5 from this side, so I take away 5, do minus 5, well, what I've got to do to maintain the balance of the equation and of the seesaw is I've also got to take away 5 from this side. So that's the general principle that we are going to follow in these equations. We're always going to do the same thing to both sides. So if we try and apply that to this second example, we've got a minus 2 equals 18, and what we're trying to do is we're trying to find the value of a. So we have to think, what can we do to get the a on its own? So if we've got a minus 2, then the opposite to that is to add 2. So I'm adding 2, but I've always got to do the same thing to both sides of the equation, so I've got to add 2 there, and so the 2's will cancel on the left hand side. Sometimes I find it quite useful to draw a mirror line down the centre, and then you can make sure you're doing the same thing on both sides of that mirror line. So we've added 2 to both sides, and on the left hand side we've got a, and on the right hand side we've got 18 plus 2, which is 20. And so we've solved that one. So the principle of doing the same thing to both sides works in all cases. So if we have 3x equals 27 and we're trying to find out what the value of x is, then what we need to do to get the x on its own, 3 times x, we have to think what's the opposite to times in by 3, and that would be to divide by 3. So I'm going to divide by 3, which I'm going to show by using a fraction there, because the bottom of a fraction is what we're dividing by. But because I've done it to the left hand side of the equation, again we've always got to do the same thing to both sides, so I've got to do it there as well. And what we're left with is the 3's on the left hand side will cancel, and that will leave me with just x. And then on the right hand side we've got 27 divided by 3, and that's 9. So we've solved that. In the next example, what we've got is y, which we're trying to find out the value of, divided by 4 is equal to 3. So what we need to do is try and do the same thing to both sides as ever, and to get rid of the 4 that's on the bottom of a fraction that we're dividing by, we actually have to times by 4. So I'm going to times that side by 4, and always doing the same thing to both sides as ever. Got times by 4 there, and so that 4 and that 4 will cancel each other out, and so that leaves us with y on the left hand side, and 3 times 4 on the right hand side makes 12, and that one's solved, and we've got y is equal to 12. In our next example we've got what we would call two-step equations, And the reason it's a two-step equation is because we're actually going to have to do two things to it to solve it. So we've got 3x plus 2 equals 11. So what I'm going to do first of all is try and get rid of this plus 2 that's on the left hand side. So to do that, I'm going to do the opposite to add in 2. I'm going to take away 2 there, and I'm going to take away 2 there, because I've got to do the same thing to both sides. So the 2's cancel, and I'm left with 3x is equal to 9. And so I'll now want to get rid of this 3, and the 3 is times in the x there. So what I need to do is divide by 3 and also divide by 3 on the right hand side. So again, doing the same thing to both sides of the equation and keeping it balanced. So the 3's on the left hand side will cancel, leaving me with just x, and on the right hand side I've got 9 divided by 3, which is 3, and so we've solved that one. In our next example, we've got x divided by 6 minus 3 is equal to 4. So again, this is a two-step equation, and first of all I'm going to try and get rid of this minus 3. So to do that, I've got to add 3 to both sides. So doing the opposite to taking away 3 is adding 3. So do that to both sides to make the equation remain balanced. And the 3's will cancel, and that's just going to leave me with x over 6 on the left hand side, and on the right hand side I've got 4 plus 3 is 7. So the next step I need to do, so the second step in this two-step equation, is get rid of the 6 on the bottom, which I'm dividing by. So that means I'm going to times both sides by 6, because that's the opposite of dividing by 6. So times by 6 there, and times by 6 there, both sides, to make sure it maintains balance. And so that 6 cancels with that 6, and we're left with x is equal to 42, and we've solved it. In our next example, we've got an equation where we've got the unknown, in this case x, on both sides. So the method in this one is to try and collect up the x's on the side with the most number of x's. So we can see in this example we've got 3x on the left hand side of the equals, and we've got x on the right hand side. So the side with the most number of x's is 3x. So we want to try and take this x here on the right hand side over to the left. And because this is a positive x, what we can do is we can take away x from it, because that's a positive x there. And so because we've took away x there, we've got to do the same thing to the other side, because it's a balanced equation. So we do that there, and these x's will cancel, and what we'll be left with is, on the right hand side of the equation, we'll be left with 2x plus 2, and because the x's have cancelled here, we're just left with 7. So now what we've got is a two-step equation like the ones we had earlier, and so I'm going to try and get rid of this 2. So I'm going to do that by taking away 2 from both sides, because that's a plus 2, minus 2 there, minus 2 there, and if I do that I'm left with 2x on the left hand side, because those 2's cancel, and on the right hand side I've got 5. So now what I need to do is get rid of this 2 that's multiplying the x, and so to do that I've got to divide this side, the left hand side, by 2, because that will cancel with that 2 there. But because I've done it on the left hand side, I've also got to do it on the right hand side to make it balance. So I'm left, if I work that out, I'm left with x on the left, which is what I want, and then on the right, 5 divided by 2 is actually 2.5. So you could do that on a calculator if you needed to, just to check, and we've completed that one. In my final example, I've tried to make this one a little bit more difficult, so I've introduced some brackets as well. So the first step I'm going to do in this one is just to multiply out the brackets. So if we do that, what we've got to do is, on the left hand side there, we've got the 5 times the x, that will give me 5x, and then 5 times 3 will give me plus 15. On the right hand side there, if I multiply this bracket out, I've got 3 times x, and that gives me 3x, and then I've got 3 times 9, and that will give me 27. So we're now at the stage we were in the last example, so we want to collect the x's up on the side with the most number of x's. So we can see we've got 5x here, and we've got 3x here. So it's the 5x that's the most number of x's. So we're going to try and take the 3x away from the right hand side, so it disappears there because that would cancel. But because we've done that, we've also got to do it to the left hand side because we need the equation to remain balanced. So if we do that, we've got 5x to take away 3x is 2x. We've still got the 15 there, and on the right hand side we've got that the 3x's have cancelled, and we've got 27. So the next step in this equation now would be to try and get rid of this 15. So because that's a plus 15, we're going to do the opposite to adding 15. We're going to take away 15, and we've done it to the left hand side of the equation. So we're also going to do it to the right hand side of the equation. We're going to do it there. And so if we do that, if we work that out, then we're left with, on the left hand side, 2x. These 15s will cancel. We chose to take away 15 from 15, so that would have left us with 0, so they've cancelled each other out. And on the right hand side, we've got 27 take away 15, which is 12. Finally, what we're going to do is we're going to divide both sides by 2, try and get rid of the 2 in front of the x. So if we do that, we divide by 2, which we can show by writing a fraction, and also on the right hand side, I should say, as well. So the 2's will cancel there, and I'm left with x on the left hand side, and that's going to equal, on the right hand side, 12 divided by 2 is 6. And we've finished. So I hope that's been helpful to you, and if it has, please consider subscribing to our channel and liking our video. Thanks for watching.